Well, hello there, this is Craig Hain talking. My students call me Dr. Dell, and you can learn all about me by going to my website at craighain.com. I'm the founder of a company called Triad Math, and as you may know, we're dedicated to having every student learn how to win with mathematics in a very quick and easy way. In fact, if you go to my website, you'll be able to download a free copy, a PDF version of my book Teaching Math, where I talk all about high school math today, how it can and should be taught, and how it can be taught in such a way that it'll work for all students. And at my website and at the triadmathinc.com website, there's a lot of free material, videos on mathematics that'll help you as a student and as a teacher teach mathematics. And then you'll also learn about a program that we have called the Practical Math Foundation, which is really the first two tiers of a six-tier program aimed at teaching high school math to anybody that wants to learn it. And now the purpose of today's video is to talk to you about something called the Pythagorean Theorem from geometry. And most of you have probably heard of it and probably even seen a proof of it. And it simply says that if you have a right triangle, that means that this angle is a 90-degree angle, or these lines are perpendicular, and it has three sides A, B, and C, that if you take the square of the two legs, a squared and plus b squared, add them together, that will equal the square of the hypotenuse. So we'll have a squared plus b squared equals c squared. Now, as a matter of fact, there's a converse to that that says that if this equation holds for a triangle, then that triangle, in fact, must indeed be a right triangle. This is called the Pythagorean Theorem, arguably one of the very most important theorems in all of mathematics because it permeates virtually all mathematics from this point forward and is extremely important. And so it's a very good thing for any student to learn in the foundation. Now, what I'm going to do in this video is talk to you about a proof that I recently discovered that is very, very simple, and in my opinion is probably the best way to teach it to a student for the first time today. But before I do that, I want to discuss the traditional way this theorem is proved in many math courses and the way it's been dealt with historically. Well, there's a marvelous book called Euclids Elements, which is the oldest textbook in the history of mankind. This book is over 2,000 years old. It was developed by the Greek Euclid. And our ancestors, frankly, learned their mathematics from this book from the very beginning up until the 20th century. As a matter of fact, Abraham Lincoln learned mathematics from this book, as did virtually all educated people who study mathematics historically. Now, Euclid's Elements consists of 13 books internally, and very few people have actually studied all of these books. Many of them, in fact, are obsolete by modern standards, but in the very beginning, the first couple of books are actually what many high school geometry courses are based on. And we're going to talk, first of all, about Book 1, which would be included in many classical high school geometry courses. And in Book 1, there are many, many theorems and propositions that they prove, mostly about triangles and that sort of thing. And it's quite an interesting thing to read. Finally, at the very end of Book 1, in Proposition 47, Euclid proves the Pythagorean Theorem for the first time. Now, this proof is not what is normally taught today in high school because it's pretty complicated. Euclid takes the right triangle and he constructs a square about each of its three sides, and then he proceeds to prove that the sum of the area of the two squares about the legs is equal to the area about the square about the hypotenuse, which is the longest leg opposite the 90-degree angle. Now, this is a pretty complex and intricate proof, and in fact, he uses a lot of auxiliary lines, as you can see here, and this is sometimes called the windmill diagram because it kind of looks like a windmill. And if you're interested in math, the theory of math, you might want to get a copy of Euclid's Elements and study this. It's a very ingenious proof, as a matter of fact. And in fact, it's considered too complicated for most beginners. And then in the very last proposition in Book 1, he proves the converse of the Pythagorean Theorem, which says that if the sum of the squares of the sides equals the square of the hypotenuse, and in fact that must be a right triangle, and that's even rarely done today in modern treatments. So let's take a look at the proof that is usually given today. It's given in just about all of the elementary high school geometry books I've seen. And I'm going to look at the one out of George Simmons' great book, Pre-Calculus Mathematics in a Nutshell. And of course, as you know, I believe that you can learn all of the algebra, geometry, and trigonometry you need from this $15 book from Amazon. It's only 119 pages long. And indeed, I've got a video that talks all about that you can get for free and access at my website. Just go to the link that is down below in this description of this YouTube video. And on page 6, he talks about the Pythagorean Theorem, and he proves it in a way that is typically done today. He simply he points out that the Pythagorean Theorem really is saying that a squared plus b squared equals c squared, but how do you prove it? And a clever proof today is to take the triangle, make 4 of them, make a square here, and do a little algebra, and you get the proof. And this is what I've seen now in most high school books, and in fact this is probably what you have used to teach your students the Pythagorean Theorem if you're a teacher, and if you're a student, this is probably the one that was taught to you. Now what happened recently was someone said to me that you can prove the Pythagorean Theorem using similar triangles. Or I think I read it somewhere actually, maybe on Wikipedia. And so I asked myself, well, how could you do that with similar triangles? So I would invite you to pause the video right now and see if you can figure out a proof of the Pythagorean Theorem using similar triangles. And then, of course, I'm going to show you what I came up with. Now, as you know, in the Practical Math Foundation, where we teach a student all of the algebra and geometry and trigonometry they need for practical mathematics in about 50 hours, this is an online, self-paced program that you take over the internet. First, we teach you how to use a calculator because you're going to do all your arithmetic with a calculator. And then we teach you the algebra you're going to need for practical math. And of course, people are amazed to find out that there's only 10 lessons in this. You don't need very much algebra for practical math. It's very easy and quick to learn, and that's the way you ought to begin your studies of mathematics. Even if you're going to be a STEM student, you want to start with the basics. And then we go into geometry. Now in geometry, there's 19 lessons actually. And of course in lesson 5, I've done the Pythagorean Theorem, and I use the classical approach. And then in lesson 6, we talk about similar triangles. And in fact, I tell you in this course that similar triangles are the most important concept in geometry in terms of practical math. You're going to use them over and over and over. And so we do a lot with similar triangles. And from this point forward, we use them a lot. Now, what had never occurred to me was to try to prove the Pythagorean Theorem with similar triangles until it was suggested to me. And that's what I'm now about to show you, is how you can prove the Pythagorean Theorem using similar triangles. Okay, in order to use similar triangles, we need to construct an auxiliary line. So we take this right triangle with sides A, B, and C, and we construct, starting from in the right angle to the hypotenuse, a perpendicular line. And now, of course, what we have is 3 similar triangles, because notice that if you take this small triangle, it has a right angle here, and this angle here are shared with the big triangle, so this angle has to equal this one, because always the angles add up to 180 degrees. So this triangle is similar to the big one. And this smaller triangle over here is also similar to the big one because they share, again, a right angle and this angle. So this angle down here has to equal this angle. And so we have 3 triangles that are similar, and that's what we're going to use to prove the Pythagorean Theorem. Now again, I invite you to take this as a hint and pause the video and do it. It's very satisfying to do this. To tell you the truth, it took me quite a while to find what I'm about to show you, but pause the video and try it, and then I'm going to demonstrate it to you the way I finally ended up with it, and the way I believe it's the simplest to teach a child today, or a beginner, the Pythagorean Theorem proof. We want to prove the famous Pythagorean Theorem, where you have a right triangle, and the sides A and B, when you square them and add them together, equal the square of the hypotenuse. That's the famous Pythagorean Theorem. Now we're going to do that in the following way. We're going to construct a perpendicular line from the vertex here of the right angle to the hypotenuse, and we're going to then get 3 similar triangles from that, because this small triangle, for example, is similar to the large one because it shares the right angle and this angle here, so this third angle has to equal this one over here. And in a similar manner, this triangle is also similar to the large triangle. Now, this short side here we're going to call x, and this long side we're going to call y, and so we have x plus y equals c. That's where we start. Now we use similar triangles. We take x and divide it by a, and that's for this small triangle. And now what is that going to equal? Well, you want x is opposite this little angle here, so if we take the large triangle, a is opposite the little angle, so we're going to have a divided by the hypotenuse, because a was the hypotenuse of this little triangle, so now it's divided by the hypotenuse of the big one. So we have x over a equals a over c. This is from similar triangles. We now use a little simple algebra and show now that x is equal to a squared over c. Now, go back and study that if you need to, using what you know about similar triangles. A very similar argument gives you the following. Take y and divide it by b, that's this small triangle here. And what does that equal in terms of ratios from the large triangle? Well, y is opposite this angle, so in the large triangle, b is opposite that angle, so you have b divided by c. So you have y over b equals b over c from similar triangles. Well, that means then by little algebra, y equals b squared over c. Now we're going to take x plus y, and that's going to be a squared over c plus b squared over c equals c. Multiply through by c, and you have a squared plus b squared equals c squared, and that is the conclusion of the proof. This is the simplest proof now that I've seen of the Pythagorean Theorem, and it uses a very simple construction and a very simple argument if you understand similar triangles. Okay, now I hope that you came up with this on your own after I asked you to pause the video and try it, especially after I gave you the hint. But it wasn't that easy for me to do, and if it took you a long time to do it, or if you didn't come up with it, don't feel too bad. Let me show you what I did initially when I tried to do this problem. I came up with this triangle here, and I called this h, this height, and then I started coming up with ratios involving h. And so I had, for example, a over h is equal to c over b, with similar triangles, and so on and so forth. And I did a lot of algebra then, and I came down and fiddled around, and I still didn't have it, and I got the h's and the x and y's involved. And then I came over here, and I just kept grinding away, and finally I got it proven. But it took me quite a long while to do this. I mean, I was thinking about it, I was trying this, I was trying that, I was using h, and finally I got done. I'm going to say this whole thing took me an hour at least, maybe 2 hours, thinking about it. And I wasn't happy with it. I thought, boy, this is a messy proof. This is harder really than the proof that's normally given. There should be an easier way. And I actually slept on it. And I got up the next morning thinking about it, and I came out, and the next morning then I sat down and I said, well, maybe I don't have to use h. And so then I went and I did it, and I came out and I came up with the proof I just now showed you without using h, and that came out to be the simple proof. Now, what's my point of this if you're a student? Mathematics is messy. It takes time to do things. You can spend a lot of time, and indeed you can make a lot of mistakes. In fact, I even made a mistake when I was doing this one. This should have been a C, and I put something else there, and then I came back and realized it should have been a C, and I corrected it, and then I got the right thing. But math is like that, and so if you're a student, I don't want you to think that when a teacher presents something and it looks so easy when the teacher does it, like the one I just did, that, oh, well, you should be able to think of it that way yourself. It's not that way. You make a lot of mistakes when you do math. You go down a lot of false paths. You try a lot of things that don't work. You have to come back and try it again. I probably put in at least 3 hours, maybe 4 hours, and plus I had thought about it some before I finally came up with this. Because someone had just given me the hint, prove the Pythagorean Theorem using similar triangles. I love similar triangles. Of course, that's what we use throughout our geometry and practical math foundation. And so I finally did it. But it took me quite a while to get this, and I wanted you to realize that. But when I finally did get it, it gave me great satisfaction. And that's what you get in math. You can struggle and work and work and work, and then finally you understand something and you see the beauty of something. And that's what I think all students need to learn when they're learning mathematics. So this is Dr. Dell. Go to my website, craighane.com, or go to the triadmathinc.com website, and you're going to get a lot of free videos there, both for students and for teachers. There's 3 books there that you can download for free. You can really join our group by opting in, and you're going to get a lot of information as time goes on. And if you decide at some point in the future you want me to help you teach math or teach your child math, then you can buy one of our online programs. They're really quite inexpensive, relatively speaking, and you can learn math. For example, you're going to learn all of the algebra and geometry and trig for practical math in about 1 semester of time, and then it goes on from there into the upper tiers. So this is Dr. Dell, wishing you a very happy math career.